Good morning, good afternoon, or good evening, everyone. Welcome to this webinar. Today, we will be exploring how to deploy applications on the edge. For those who don't know me, my name is Marcelo. I am TagoCore content editor, and with me today I have Fabio Rosa and Klaus Borges. Right. So before we start, I would like to remember you all that our chat is open. Right. So please present yourself there. And our Q&A is also open and it is located above our chat. So there you can ask all your questions that in the end of the presentation, we will answer them now. Right? So to be a little bit more specific, today we'll be talking about TagoCore, one of our new products. Right? TagoYo already have thousands of applications on the cloud and we are now presenting this new product right for those who needs an application on the edge. Of course, with that there are some advantages that you'll be missing from our cloud platform, but you will gain other parts of it. Right. So our schedule for today. First, we will talk about why TagoCore, right? Why is it important? After that, we'll take a look at its architecture and features. And then we'll have a live demo, which is the biggest part of this webinar. And finally, our Q&A, where we will answer all of your questions, right? So without further ado, please, Fabio.
Great. So, thank you everyone to be here with us today. We're very excited to continue talk about the TagoCore. As Marcelo mentioned before, that's our new product, and we have a lot of people using. And we want to make sure that we not only talk high level about the advantage, what's TagoCore, but also go into details. So, what we want to do today is not only talk about why you may use TagoCore, but also talk about architecture and present life. Okay, so first of all, it's good to remind that we have two products. Okay, Tago IO that you can see here, the screen is for the administrators, for the developers to create their solution. And then you have Tago Core that is a nice set of features that allows you to deploy the application for your end user on the cloud as well. And the Tago Core comes something not in the middle of both, but the middle between the cloud and your device. As I talked before, Tag IO allows you to send data to the cloud so you can process. There are a lot of advantage going to the cloud, but let's talk a little bit about the challenge. So if you get a typical IoT application at least high level, we can say that you have on the edge or close to your sensor or those who are getting information, you have devices there that normally are going to be able to send data to the cloud. So you may process data locally a little bit, what you call end devices. Then you send this data to the cloud, and on the cloud is where we do normally a lot of processing. Is that where you would normally add intelligence? But there are some challenges. First, latency. In many cases, latency may not be a problem at all. And I'm talking about the milliseconds, right? 20, 30 milliseconds, depending where your server is, depending something in the middle. If you are located here in the United States, your sensor is here and you access from here, you have one latency. If you are in other place, far from here, can take a little bit more time. There are also connectivity costs, so may not be for free. If it's connected to the internet, maybe send data can be just a few data points, can be using your local internet. Wi-Fi may cost zero, but if you go through cellular or satellite, that can cost a lot. Then you may also have some concern with the privacy and security. Okay, we have this challenge. So why are you using cloud anyway, right? Why we're doing that? First, to be fair, it's easy to scale. It doesn't mean that can be always cheap, but it is, right? because if you go and use our server or using other servers, you expect that you can easily scale, and that's true. So you have basically unlimited processing capability. And also to manage the product during its life cycle is very easy because it's centralized. So if you deploy something in your application, you press a button, you update it, in a few seconds later, pretty sure you're gonna have everything up and running with the new version. When you do this on the edge, you need to have a mechanism that will allow you to send the code down, check if everything's fine, reset the device, and start again. So it's very easy with the cloud, but there are some challenges. So there are pros and cons. So what's the proposal of TagoCore? TagoCore, first of all, is a free IoT platform that's open source that we are providing for to people to use the way they want. They can use it, install on the edge or even on the cloud on their own servers, and get a lot of advantage. Let's talk just about the edge by now. So what we want to do with TagoCore is allow people to extend the cloud capability. Okay, so we are able to get a little bit of an intelligence or as much as possible in terms of what's available on your edge computer to the edge. So you bring intelligence to the edge and you combine with the cloud. It's not like just one or other. It's not like I don't need the cloud at all. Maybe that can be an option, but normally you may be going this direction to have a combination of both. Let me give you one example here very quickly. So let's say that you want to apply edge in an industrial application. So if you have a lot of sensors located inside the industrial plant, for example, a chemical or any kind of manufacturing line, you want to send this data to your server internally or to the cloud and notify people. Um, you may need a better architecture that allows you to have higher availability and better integration. How you can do that? You can do that, for example, by using TagoCore. If you see here this diagram, you see three main components. On the left, you can see TagoCore, where you have, let's say, a local computer, can be very small, like a Raspberry Pi that costs just few dollars or less than $100, or can be your computer, a Mac, industrial computer, can be even your local server, but it's local inside of your manufacturing plant. So there you can use a lot of features that you have available. For example, with Itago Core, you can store data, you can process data, use the connectors to connect with LoRa, um, HTTP, MQTT. So there are a lot of things that you can do, and you're going to see this in the detail during the presentation. But you can process everything locally. Then you can send it to Tag.io. You may not be needed to send everything to the cloud. For example, you can get a lot of data from a machine every fraction of a second and send this data to your local storage and send it to cloud just a little bit. For example, the result of the processing that you do every minute, day, hour is up to you. Then on the cloud, you can use the good advantage of Tag.io, where you can integrate with your enterprise system. You can execute very advanced algorithms, let's say with machine learning or generate reports, aggregate the data. You can do that. And then if you want to send this information, present to the users, you can still benefit from Tagorun. There is where you are going to create policies to allow to determine who is going to access what. For example, you can give information about one plant, one site, one administrator, one supervisor, and then you can give information from other sites to other people. So you can take advantage. So that's the beauty of Tago Core. It's not a system that you just run on the edge, but that can run on the edge and it also allows you to take advantage of Tago IO and Tago Run. So very quickly here, just reinforce that you can run basically in any computer. Okay, if it runs Mac, Linux, Windows, you can install. Of course, we know people are going to use this in their own computer, but we expect people use more this on industrial computers. And here are some examples. Also, we created TagoCore in a way that it is based in architecture that fundamentally use plugins. So that's very nice because TagoCore is very light, it's very small. The code is very small, very powerful because you can install the plugins that you want. For example, if you want a certain type of database, you can use the uh, SQLite. If you want Postgres, you can use as well. MongoDB, you can add the plugin. You can use the connectors for integration with powerful analytics, Node-RED, things like that. That is just a very high level introduction. Now I wanted to invite Klaus to talk about the Tago Core architecture, and then he'll go ahead and present a live demo. Klaus?
Hi everyone, I'm Klaus. I'm a developer here at Tago.io, and I'm very excited to be here today talking about TagoCore. You might know me from a series of webinars on Tago.io admin. I'm a front-end developer here, but I'm also responsible for the development of the front end for the TagoCore console. My presentation today is going to be divided in two parts. The first part is this one you can see on the screen, which I will be giving an overview on TagoCore, and I'll also be talking about the architecture, the base architecture of TagoCore. And then for the second part of my presentation, I will be making a quick showcase of a use case where you can run three different instances of TagoCore and manage a queue plugin to receive the data and manage multiple tons, like a ton of requests per second. So make sure to stick around for the last part if you're already familiar with the basics of TagoCore. I'm going to be talking about the architecture now. So as you can see on the screen, the base architecture of TagoCore is that you have the TagoCore API, which is running on the edge or on the cloud or on your local server. And this API is accessible from two ways. You can access it with the console, which is built in into TagoCore, and you can also access it through the API itself by using a tool for making requests, HTTP requests like Postman or something like that. Once the data from your devices reaches the TagoCore API, as you can see on the screen, it will be passed into the encoder plugin, which it then will be passed into the payload parser. The payload parser, as you know from Tago.io, will handle your payload and format some data if you need to treat it immediately once you receive it and not afterwards with an analysis, for instance. After that, if you have a queue plugin set up on your TagoCore instance, this parsed payload will be passed into the queue and it will be treated. And after it's treated, it will be queued and it will be sent to the data orchestrator once it's ready to write to the database. Because if you look at the data orchestrator part, it mostly handles sending the data after parsing the payload to the database plugin, which you have set up on your TagoCore. But it might trigger some actions or it might trigger some analysis. You have real-time events, you have statistics. There's a lot of things that the data orchestrator handles at this point. So as you can see on the screen, there's a lot there in the middle section. But for a higher level overview of this, basically think that if you have a queue, the queue will handle storing the data for for a few seconds at least, until the data orchestrator is ready to pull the data from the queue. This might mean also that if you have some failing states on your database, you can have it handle redundancy for that. You can have the data stay on the queue and then pull it once the database is ready again. So you can see this as a redundancy strategy as well. queue is not only for handling multiple requests, it's also for redundancy, like I mentioned. So this is an overview of our architecture. Of course, there are plugins there that extend the functionality from TagoCore. You might already know a few plugins, at least the database plugin, which is mandatory for TagoCore, since the TagoCore doesn't handle storing data natively. It needs a plugin. It's one of the main points of the performance for TagoCore is that it's very slim and it's very extensible and very powerful by default. So when you think about plugins such as the database plugin or the queue plugin, which are both showcased in this screen, you can think that these might be essential for you, but they are also extensions for our core functionality. So this is the basic overview of the architecture. Of course, I kind of condensed the knowledge a little bit, but if you have more questions, you can ask in the end of the presentation. Just as a side note here, I will not be talking about clusters today, but they are a very powerful feature when you want to integrate your TagoCore instances with TagoIO Cloud. If you want to show data from your TagoIO instances and your devices that are sending data to your database stored locally, you can use not only the TagoCore integration with a single instance of TagoCore, but you can also use the cluster mode and make a cluster of TagoCore instances, which can then be used to show data on dashboards in real time. This is covered by a series of webinars that Matt presented a while ago. If you want to look into more information about it, you can check our YouTube channel. There's a lot of other webinars about TagoCore there. If you have any questions, you can ask later in the presentation. So now I'm going to be moving into the demo. So I'm gonna start sharing my screen. Just a second here. Okay, so here for my screen, as you can see, I'm just showing at the beginning, let's just hide this. Okay, so I'm just showing the main page of TagoCore, which is where you can locate the downloads if you want to install it locally on your computer for testing, or you can download it to install it on the edge of like a Raspberry Pi, and you can access the documentation. I will be talking about the documentation a little bit later and the community, just to show you that the TagoCore is an open source, the TCore is an open source project, and we have TagoCore built for TagoIO, which has the plugin store integration and many more features that you can use to improve the experience and add additional functionality to TagoCore. What I'm going to be doing today is deploying TagoCore on the edge, but unlike a previous presentation that we had on a webinar by Matt, I'm going to be doing it using Docker. This is I chose using this architecture for deploying because I can handle multiple instances in a single machine, which is my server. I'm going to be using this for the later demo, but I'm going to be talking about this by running the TagoCore on Docker. This resource is available on the TagoCore page as well. It's not located on download, but you can see it in the documentation if you want to see, or you can just Google Docker TagoCore and you will find this page. And it's very simple to use it. I'm going to be showing this right now, but you can look at this documentation. It's basically you just need to run this command, and it will run the TagoCore instance on your machine using Docker as a container. And you can see that this is mapping the ports. This is an example, but you can also use the environment variables as defined here. I'll be showing this in the terminal. Just let me pull it here. Okay, so I hope this is big enough here on the screen. But here I'm running on my server. So you can see that if I run Docker PS, I can see that I'm running 3 different instances of TagoCore, one in each port. The port is hidden on the command itself, but I'm going to be showing you how I set the port here. And I'm also running an instance of the Postgres database. This is what I chose to illustrate how you can have multiple instances writing to a single database, which is a failover strategy, which you can use like hosting this database on the clouds in a cloud provider, where you can host it on your own server, and you can have your TagoCore instances on the edge, such as Raspberry Pis located closer to your devices, and sending the data to the same database, which is what I have set up here. So these three TagoCore instances, which I'm going to be showing in the console as well, are running on Docker. And then I have the Postgres database also running here on Docker. And the way you do it is just you can run this command, which is basically the same as the command on the documentation. We have the ports mapping. The second part is the port for TagoCore. So this is fixed, and the first part is the port you want to open on your machine to be directed to this port internally. I'm not going to be talking in depth about Docker here, but this is also a command to set the environment variable. Since I'm using this parameter here, which makes everything on Docker be accessible to my machine, I don't need these two port parameters right here. I'm sorry, I was using the keyboard here, but I don't need these parameters since I'm using these two. If you want this, you can use it like this, and it would work flawlessly. So this is what I need to run a TagoCore instance like we have up here. And now I'm going to be showing you how it works. So I'm going to be closing these two tabs really quick. So here I have one of the running instances from my TagoCore setup. You can see it that it has one port, and I have the two other instances right here. They are, like I said, connected to the same Postgres database, as you can see here. They're all using Postgres. And they're all in different ports. This is 8992, and this is 8990, and the other one is a different port as well. So those are three different instances. They're all set up to the same database because I want them accessing the same data store. When we're thinking about deploying to the cloud, it's important that we keep in mind that if we want persistence and it's shared, we can't use a SQLite database like I disabled it here. This is the usual plugin that is demonstrated here on our webinars. I'm going to be doing something a little bit more complex here, but it's fairly easy to set up, and you can ask on our community if you need help setting it up. So we have a Postgres instance shared by these three TagoCore instances. So what I'm showing here is basically the same. I have the same devices for the three instances since they are using the same database. I have the same user, the same buckets. Analysis are run separately. So I can have analysis added to this TagoCore instance, and it will not be automatically shared with the other instances, which this way I can process data in one instance different than the others. So I'm going to be talking just a little bit about this setup, just so we can highlight the benefits of using a distributed TagoCore instance on the edge architecture. So here's what I think with this scenario, just really quick. I have my centralized database, like I mentioned. It's a single instance shared by the three TagoCore instances. And each instance is receiving data from devices, and then they are sending it to the same database. So these devices would be mapped to this database. This database has the IDs, the name, the configuration, and all the data for these devices, and these devices. But if you look at this a bit abstract, this layout that I designed here for this diagram, you can think that this instance is running on a region, such like a state in your country, and this one is running on another state, and this one is running on another state. This means that these instances are far away from each other, but they are using the same database, which can be located on a middle point or something, anywhere you want. It can be located closer to one of these instances. It doesn't matter. This is up to you. What this brings as a benefit is that you can have these instances writing to the same database, and the devices sending the data to these instances receive the response very quickly that the request was accepted. So if we have a device here sending it to this third instance, which is the green one, I'm going to be referring it to these instances as colors to make it easier. So these devices are sending data to the green instance, and the green instance is sending the data to the database. The same goes for the blue instance and the orange instance. But these devices are closely located here. So the latency here is really, really low. So these devices receive responses almost immediately. This is the case unless you're actually accessing data from the database. So if these devices pull data from the database, then they will have to deal with this path here. But you can do caching on this instance. You can do a lot of things, especially with the extensibility of TagoCore, which you can add plugins for caching. You can do local caching. You can do duplication on the edge for your database. There's a lot to talk about here. Unfortunately, I won't be able to. Like deployments on the edge for a lot of applications is really a moving target right now. There's a lot of improvements being made, so you can have databases on the edge as well. There's a lot of improvements being made. So look at that space if you want to work on the edge, because it's very, very, very exciting. So just this is a quick overview of what I'm going to be demonstrating. Is I'm going to be simulating these three instances receiving data and sending it to the same database, where one of the instances, I forgot to draw it here, but this instance will have a queue plugin. So it will handle the queue before sending it to the database, unlike these other two instances I'm going to be talking about later. So I'm just gonna to be moving with the rest of the presentation about TagoCore. So like I was mentioning, the analysis part is located on your TagoCore instance. So if you'll see here the screen where we can have a new analysis created, you will choose a binary executable path, which will be the executable that will be running your analysis script. So you can use something like user bin node, which would be the node JS runtime, and you can add a script here by like home, let's say home clause, and then my analysis.js. This would mean that my executable would run this analysis, and this analysis would have to be located on this instance. I'm going to be calling this instance number one, which, if you recall, is the orange one. So this orange instance has this analysis, and if you have something like an action, which you can use to, for example, you can have an analysis that, you can have an action that triggers an analysis to send some data to the TagoOL cloud, for example, if you want to do manual synchronization for some data points. Let's say that you want to the TagoOL cloud receive data when the value exceeds, I don't know, 100. So you can have an action that triggers when the variable receives a data point that exceeds the value 100, and it will trigger the analysis, and it will send data to our cloud, which you can use to display on your dashboards or even send alerts, but it will be stored on our cloud as well, which is optional. So like I mentioned again, just to be sure, that this is mentioned a lot on the presentations about TagoCore, and Fabio talked about this a little bit as well. But the data that you are storing in your TagoCore instances can be located in SQLite files, which would be using the SQLite plugin, which would be files here located at each instance. And you can have an approach like this, which can be a Postgres or MySQL database that is located somewhere on the cloud, on your servers, on the edge. You can have it receiving data, but this data, even in SQLite, Postgres, MySQL, Mongo, if you write a plugin for it, or or maybe we'll release one later. But if you have this database, the data is located and fully in your control. You don't have to synchronize it with our cloud. You can use our cloud for storing data where you need more availability. Because think about it like this. Your database instance might be located at AWS. So it might have some reliability and some availability that is guaranteed by the platform. But maybe you're running this database on your server, and your server maybe resets, or maybe there's an upgrade that it just reboots, I don't know, or maybe just the power goes out, and these instances cannot contact this database anymore, which also means that you don't have access to this data in real time anymore on your dashboard. So you might have an integration that sends data to Tago IO Cloud to have your data available at all times. This is really important because, like I mentioned, most of our webinars talk about SQLite, and it's very interesting approach when you're testing, when you're not familiar with setting up a database like Postgres, but it's fairly simple. You can use Docker for this as well, and you can have more control of your data. And you can have a scenario like this one, which is not, you can do it with SQLite as well, but it's not really easy to do. If you want to share a database with multiple instances, since it's a file located at some place, it has some limitations. If you want to have this file located on a separate server and write to it, it might have some concurrency issues or something like that. So databases handle this quite nicely. Okay, so let's go back to this. I was talking about analysis and actions. I talked about devices. Like I mentioned, this is a really quick overview about TagoCore. So you can have these devices set up. I'm configured this one, which will receive data from the queue. These two won't have data from queues. Analysis, like I mentioned, you can add to process your data after it's parsed by the payload parser and sent to your devices. You can have actions to trigger analysis. You can have actions that dispatch notifications, very similar to what you can have on TagoIO Cloud, TagoIO Admin, TagoIO Run, Tago Run, sorry. And as the last part I want to mention here before going into the demo, I want to talk a little bit more about the setup itself. Just a second here. Okay, so like I mentioned, I configured these three instances to use Postgres. The configuration here is fairly simple, and it's the same for all the instances. Like I mentioned, I'm using the same database located on a Docker container. So I'm just setting up like localhost here. It's the ports. It's a simple setup. And I'm telling the plugin the name of the database. This is very important, as well as these fields that are marked required. And I just left it like this because it's inaccessible to the internet, so it's fine. But I'm using this user Postgres and no password here. But think about this when you're deploying this database to the cloud. You don't want it to have no password. You don't want to have it want it to have a simple password. This is just because this is a local setup. So I have this user Postgres, which will be writing to the TagoCore database. This setup is the same for all the instances, like I mentioned. Just to show it here, it's just the same. Using localhost, the same ports, the same database, the same user. So other than that, I also set up the RabbitMQ plugin. I chose to use RabbitMQ here because I can install it locally, unlike Amazon SQS, which was demoed by Matt on another webinar. So for this queue, I wanted to run on RabbitMQ. So I'm just configuring one instance, which I'll be talking about why just in a few seconds. So I configured it to have the local host. I'm configuring the ports. I'm configuring the queue name here. This is whatever you want. I will be showing the management screen briefly. And of course, we have a user and a password. Here I put some password. And this is also important. We're going to be fixing this. This is also a required field. If you're setting up RabbitMQ, do not forget this one because it will throw some errors on your console if you don't set the message time to live. Think about this. This is the time that the message stays on the queue, and it will be discarded if it's not processed after this amount of time in milliseconds. So my messages in this queue are going to be expired once they pass 1 second in existence. Okay, so this is about it for the setup parts. It's fairly simple to set up RabbitMQ. You can also use Docker for this as well. I didn't use Docker because I test RabbitMQ sometimes. And you can use SQS. Like I mentioned, there's a webinar talking about SQS. When we released the Q plugin, we talked about it on our webinars. And then let's just go back really quickly to this diagram for one last time. So imagine that we have a queue here. I can't actually just fix this. Let's just do this like queue here, just so we can see it. So this instance has a queue. So before anything is sent to the database, the data received by these devices into this instance will be sent to the queue. So the queue will be here, and the database will only receive the data once it's ready to process. So let's say that this instance that doesn't have a queue and this instance that also does not have a queue, they're sending a lot of data and a lot of requests, and the database is really busy writing. The database will handle it nicely, but the requests will be the response times will be a lot bigger because the database needs to tell this instance that it finally finished writing, which is handled by the orchestrator, like I mentioned in the architecture overview. Unlike this case, for this instance, the data will be sent directly to the queue. This is for read only. I'm sorry, for write only. This is not for reading. So the queue is used for writing. The data is sent to the queue, and when the database is ready, the data orchestrator will send it, and the database will write and persist the data on your store. Okay, so this is a lot. There's a lot to unpack here. I'm going to be showing you the demo. I'm going to be talking about how I structured this a little bit, and then I'm going to be wrapping up the presentation just in a second. Okay, so here's my setup. Let me clean this a second. Okay. What I'm doing here, just so everyone knows, you don't need to think about this command right now. I'm just sending a bunch of requests to each instance. So this panel right here on the left side is sending data to the first instance, which is the one that has the queue. The second panel here and this third panel here, these are sending it to the instances that do not have a queue. And other than that, I'm going to be showing you, this is what the management screen for the RabbitMQ. We can see here that I'm looking into one of the queues, which is the one I configured on the instance. And this is the chart that will be displaying the messages on queue. I'm talking about this in a little bit of advance. So when I show this, it's not unclear to everyone what I'm talking about. I'll be also showing you the homepage, which we are going to be able to see the input. And like I mentioned, just as a last note before I start the demo, these instances are all using the same database. So all the data will be recorded in this chart. Okay, so it will have a lot of inputs here. All right, so I'm going to be starting the demonstration really quick. So here I'm going to be showing you just the base interface, just so we can appreciate how this looks. This is sending data, a lot of requests per second. This instance is receiving 100 data points per second. This one as well, and this one is receiving a little bit less. I configured it this way. So you can see here the requests are going to be running for 2 minutes, and we can see here that the status code distribution, it means that each of these requests are being filled by the API. It's not crashing, it's not telling everyone to wait, it's just works. And this one is being sent to the queue. I'm not going to be showing this interface that much because this is just automation to send requests, a lot of requests per second. Like you can see here, this one is sending 1,000 requests per second. This is a lot. We can see here the data inputs are rising, and we can see here that it's really, really quick. And our devices and buckets are also showing this. These were all blank before. You can see here. And before I forget, I'm going to be showing you the queue. We can see that the queue is receiving a lot of entries, and it's processing it really, really quick. We can see that the amount of messages in queue is 6 at the peak here. And our demo is almost ending, and it's just shy of 30 seconds for it to end. I'm not going to be running everything. I'm not going to be showing everything here, but it's almost over. And we're processing the data, and one of the instances is receiving now 6,000 requests in a minute. It's a lot. I'm going to be showing it one last time here. So it's a lot of requests and it's processing it really, really quick. So you don't have to worry if you set up a queue plugin like this. Your data will be safe. Your data will be delivered to your database. Well, make sure your database has some availability thoughts going into it, such as using a cloud provider for your database or something like that. But as you can see here, the queue just dropped and there's no more messages to be processed. And we can just wrap up this presentation by seeing here, I'm going to be refreshing. So this device with the queue received 12,000 data points. This one received 1.2, and this one received 200, around 200 data points, data records, I'm sorry. So these three devices process perfectly fine. There is no performance bottleneck here. We have one single database being hit with a lot of data points. You can have multiple instances doing the same thing. You just need to think about the queue plugin, and if it's an instance that it's receiving a lot of data, you might want to set it up. It's fairly simple, and it will increase the availability of your service, and your database will be really happy about it, since it will not receive a lot of requests for writing at the same time. So just to finish here, this is the final mm, result here. So we have 1 minute that received 4,000 requests at data records. This one received 7,000, and this one receives 3,000. I'm sorry. So this is it for my part of the presentation. If you have any questions, feel free to ask. I hope this helps, and I hope it was really exciting for you to see uh, a valid use case for queues for multiple instances of TagoCore being located closer to your devices to reduce latency while still using a centralized database to receive the data for all instances, from all instances and from all your devices. So this is it for me.
Thank you very much. But it was amazing. It was an amazing presentation. It's always good to see how far we have gone with Taco Core, right? How much it has evolved. Okay. So, guys, before we jump to the Q&A and see if you have some questions, I would like to remind you all that this recording, right, it will go up on our YouTube channel and you will receive an email with it, right? We're also constantly having webinars, okay? This one is the last one of the year, but the next week we will be back, right? So please, you can follow our webinars on our event page, or you can also subscribe to our newsletter. There, you will we will tell you every time we have a new webinar, and we will also send you some news about the IoT world, right? So, Fabio, do you want to say something?
Oh yeah, I want. That was a great presentation, Klaus. It's really very exciting to see this point that you reinforce a lot about the queue, right? Because when we talk about edge, there are a lot of concern about reliability, right? We want to make sure that we don't miss data. And just with this example that you show is very aggressive. So if people have something like a small computer getting a lot of data, or let's say not much data, but everything is stable, but suddenly there is a big peak, right? They don't need to pay for a lot of a computer. They can use the queue to store the data so temporarily, and don't miss any data point. So reliability, availability is very important, and this plugin that you presented today is really doing the job. Is very nice, very very well done. I really appreciate, and I know that a lot of people is asking for that, because again, every time they talk about serious IoT, they need something like that. Okay, and there are more capability. You had no time. We had no time to show other things, the integration with Talgo.io, the dashboard, all things that you can do, but this part is well covered. Yeah. Yeah, I think that are just a comment, no additional question. So good.
Yep. So, thank you all for coming, right? For today, that was it. We see each other next year. Bye, everyone.
Bye. Thank you.
Happy holidays.